with number 9 here, we're starting with an isosceles trapezoid, and we have AB equal to CD. So we know that these two legs are equal. Now, anytime we see this altitude being drawn in, we almost always want to add another altitude on the other side here. So if we drop another altitude from C, we'll call this point F. We know we're going to end up with our right angles, our congruent legs, and our base angles congruent. So the cool thing about this, or the thing that's important here, is these two triangles are going to be equal to one another. And because they're equal, we are going to end up with a rectangle in the middle and two equal triangles on the outsides. So we'll know if this top line is 12, that this bottom section from E to F is also 12. And the reason we know that these two triangles are congruent is because they have congruent legs, base angles, and right angles with angle side. So we'll know that these two triangles are equal, all right? And that means we can figure out the distance from A to E, and that's the same as F to D. And so if we just take 22, subtract 12, which is on the bottom here, this whole piece was 22, we'll get left with 10, and that each of these has to be 5 in order for that to be true. Now from here, in order to find the length of this altitude, this length BE, which is what we're looking for, we're going to have to use some Pythagorean theorem. So remember that A squared plus B squared equals C squared is kind of the same interpretation of leg squared plus leg squared equals hypotenuse squared, and the hypotenuse is always across from that right angle. So we're going to want to create an equation where 5 squared plus x squared equals 13 squared. Remember, we're going to square those numbers first, get the x squared term by itself, and then square root both sides to get our answer of 12. All right, and then for homework tonight, I would like you to finish up pages 20 and 21 with the review of our quadrilaterals unit. All right, we'll see you guys tomorrow.